Okay, so in this first example, we're going to take a look at the diagonals of a parallelogram and explore how that will help us to identify a rhombus. So in parallelogram ABCD, we are given the information that AC is perpendicular to BD. So here's AC, that's one diagonal. Here's BD, the other diagonal. We can see there's already a right angle put in there, so there's our perpendicular. What else can we conclude about this figure? So it's a parallelogram. We can see they marked our opposite sides parallel for us, and then we've got the perpendicular diagonals right there. So let's just start listing off the things we know. Well, this is a parallelogram. That means that those diagonals bisect each other. So if we look at our picture, we can mark what would be congruent. If the diagonals are bisecting each other, then AE will be congruent to CE. We can write that in. AE is congruent to CE. And then the other diagonal, DB, got bisected as well. So DE will be congruent to BE. We will put a comma. This is what we know from those diagonals bisecting each other. So DE is congruent to BE. All right, we also know that there are 4 right angles at E. That's what the perpendicular diagonals gave us. I'm going to go ahead and draw in the rest of those right angles so we can see. Yep, there's 4 right angles. So really what we have are 4 right triangles. And these 4 right triangles are all going to be congruent. If we look at the congruencies we just marked, we have, if we focus on, let's just say this top triangle, AEB, we have 2 sides marked congruent with the included angle at 90 degrees. If we look at all the other triangles, we have the same 2 sides congruent with that 90 degrees in the middle, same 2 sides, 90 degrees. So this is a side angle side congruency. So we're going to say that all the triangles are congruent. And we're talking about those right triangles formed by those intersecting diagonals. And I'm just going to do a little abbreviating. All triangles are congruent by side angle side. So by CPCTC, corresponding parts of all those congruent triangles will be congruent. We know that all the sides of the parallelogram are congruent. So those sides that we're talking about, we're talking side AB is congruent to side BC, is also congruent to side CD, is also congruent to side DA. So if we mark that in the picture, you have 4 congruent sides, and you have diagonals that bisect each other. Therefore, so taking all that information into consideration, this is a rhombus. So what we were able to get to were these 4 congruent sides. So that's what made this a rhombus. Okay, so we've got a theorem about diagonals being perpendicular. If the diagonals of a parallelogram are perpendicular, so first of all, we have a parallelogram. Let's label our picture a little bit. We can go ahead and put in some vertices. So we have J, K, L, and M. We know it's a parallelogram, so opposite sides are parallel. So let's just go ahead and mark those opposite sides parallel. So there's our parallelogram. So if the diagonals of a parallelogram are perpendicular, so here's our diagonals of a parallelogram perpendicular, then the parallelogram is a rhombus. So if it's a rhombus, that means we're going to have 1, 2, 3, 4 congruent sides. So JK will be congruent to KL, which will also be congruent to LM, which will also be congruent to MJ. All right, our next theorem is when an angle is bisected. We didn't take a look at this in our example above, but we're just going to add in this theorem. Let's go ahead and label the vertices of this figure. We'll use A, B, C, and D. So if a diagonal of a parallelogram, so again, it's another parallelogram, so let's just mark those opposite sides parallel. Just so we're remembering, we are talking about a parallelogram, opposite sides are parallel. If a diagonal of a parallelogram bisects two angles of the parallelogram, so here's a diagonal, it's bisecting angle B and angle D, so when that happens, then the parallelogram is a rhombus. So if you have a diagonal bisecting two of those opposite angles, you've got a rhombus, which means all four sides are congruent. Now that we know it's a rhombus. So then AB is congruent to BC, which is congruent to CD, which is congruent to DA.